Astronomers have detected the first exomoon, opening a new window on how satellites form beyond our solar system. This is Fascinating Frontiers, episode 148. The candidate orbits a planet or brown dwarf roughly 12 times the mass of Jupiter. Detection relied on transit timing variations and gravitational microlensing signatures captured over multiple epochs. Ground-based surveys supplied the photometry even though no single named instrument is credited in the report. The moon's inferred mass and separation sit outside expected ranges for both in situ accretion and capture. Follow-up observations with larger telescopes are planned to confirm the signal and refine the mass ratio. Now shifting to an unusually shaped small body closer to home. Sharp images from two large Earth-based telescopes show two deep valleys encircling the 75-kilometer asteroid Nysa. Researchers interpret the valleys as contact necks linking three separate lobes. A previously unknown kilometer-scale moon was also detected in the same dataset. If confirmed, Nysa would be the first known three-lobed minor planet. Additional light curve and radar observations are needed to test the rubble pile interpretation. The three-lobed shape proposed for asteroid Nysa would make it the first known contact body with two distinct necks. The valleys visible in the new telescope images run completely around the 75-kilometer object, suggesting the lobes never fully merged after a gentle collision. A kilometer-scale moon discovered in the same dataset may have helped stabilize the unusual configuration through tidal interactions. If rubble pile models hold, Nysa preserves a record of early solar system collisions that most asteroids have since lost. The next step is targeted radar or spacecraft flyby imaging to measure the internal density distribution. Nysa's rubble pile nature leads naturally into how such loosely bound asteroids avoid breakup. Picture a city-sized pile of gravel and ice drifting between Mars and Jupiter. If every fragment were scaled to the size of a suitcase, the whole asteroid would still span dozens of kilometers yet contain more empty space than solid rock. When two such loosely bound objects meet at walking speed, the impact energy dissipates through rearrangement of the fragments rather than explosive fragmentation. Inside that gentle collision zone, the typical fragment travels only a few meters per second relative to its neighbors. The same low velocity also explains why some rubble piles end up with multiple lobes separated by narrow necks. Laboratory experiments on Earth struggle to replicate the vacuum and microgravity conditions that govern these bodies over millions of years. While rubble piles quietly rearrange themselves, an ancient captured moon may have violently reshaped an entire satellite system. Triton's capture is thought to have disrupted an earlier satellite system whose fragments now form the dusty rings around Neptune. The study models how larger precursor moons were shattered and reaccreted into the current small inner satellites. Remnant material supplies the observed ring mass. The work uses N-body simulations tuned to match the present orbital architecture. Future missions carrying dust analyzers could test the predicted ice compositions. Triton itself accounts for more than 99.5% of the mass among Neptune's 16 known moons. From disrupted satellite systems to the spin history recorded in one of the largest moons we have visited. New Horizons flyby data revealed tectonic features on Pluto's largest moon, Charon. Models indicate Charon once spun roughly 10 times faster than its current synchronous rate. The rapid spin would have generated stresses sufficient to fracture the crust and raise the observed mountain ranges. The moon's mass is 1/8 of Pluto's, the highest satellite-to-planet ratio in the solar system. Further mapping of fault orientations could tighten the spin-down timeline. Past dynamics of known worlds give way to technologies that could one day reach entirely new ones. Concepts under discussion include nuclear thermal and nuclear electric propulsion systems. These designs aim to shorten travel times to the nearest stars from millennia to centuries. The article reviews propellant heating cycles and reactor mass budgets, but supplies no specific thrust or specific impulse figures. Ground testing of reactor components remains the next engineering milestone cited. Long-term propulsion ideas contrast with nearer-term observing plans visible right now in our skies. Observers can watch a solar eclipse, a deep partial lunar eclipse, and the Perseid meteor shower. Venus reaches peak evening brightness during the same period. The agency's monthly guide lists optimal viewing times by longitude without providing instrument requirements. Public outreach events are scheduled at several NASA centers. The Perseids stand out as one of the year's most reliable annual showers. While we watch the skies from Earth, spacecraft already up there are preparing for their own orbital adjustments. Catalyst space teams continue to reduce the spacecraft's rotation rate on the Link mission. Link is intended to raise the orbit of NASA's Swift Observatory. Progress is reported through ground station telemetry, but no numerical spin rate values are given. The mission remains in the stabilization phase. Swift itself continues routine ultraviolet and X-ray observations while awaiting the potential altitude adjustment. AI algorithms trained on wide-field imaging have identified 7 new quasar lenses. Each system is gravitationally lensed by a foreground galaxy, stretching space-time on arcsecond scales. The sample expands the known set of quasar lenses useful for measuring black hole growth and galaxy evolution. Spectroscopic confirmation with large telescopes is the immediate follow-up step. New maps combine orbital neutron data with statistical confidence intervals to show where water ice is probable near proposed human landing sites on Mars. 2 papers from the Planetary Science Institute outline these locations without stating absolute ice mass values. The work identifies instruments needed to raise map certainty above current thresholds. Landing site planners can now prioritize zones with higher ice probability. Deep imaging has reached the outer edge of galaxy IC 1101 for the first time. The measured stellar extent is 520 kiloparsecs, equivalent to roughly 1.7 million light-years. Total stellar mass is estimated at 3.4 trillion solar masses. The observations used large ground-based telescopes under excellent seeing. An engineering model of a Mars rover is under consideration for lunar surface operations. NASA's administrator rejected the cost estimate as too high. Concept studies continue at lower fidelity. The Flight Dynamics Research Facility at NASA Langley began operations on July 31st. It is the first major wind tunnel at the center in more than 40 years. The facility will test aircraft, rockets, and exploration vehicles. Virginia government officials attended the ribbon cutting. Before we go, keep an eye on spectroscopic follow-up of those new quasar lenses and the next stabilization updates from the Link spacecraft. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NARA Network, links in the show notes. This show comes to you from the NARA Network. If you want another sharp daily briefing, Models and Agents has you covered. Your daily briefing on AI models and agents. All our shows are free at naranetwork.com. Live dashboards, TSLA, SpaceX launches, the investing scoreboard are all at naranetwork.com data. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly through